So today we are looking at HMI. Firstly, my name is Victor. So I work here in Delta Electronics. I'm in the Department of Control Products. In Delta, we have this group of products. We call them control products. So today we are going to be looking at one of the control products called HMI, Human Machine Interface. So this is our course outline. It's more of introductory to HMI. So we'll have an overview of the HMI that we have in Delta, and we'll also have an overview of the HMI fixtures. What are the smart fixtures you can accomplish on your machine when you use our HMI? And then before we bring the training to a close, we just have a feeling of the software, the different functions in the software, and how you can program the HMI. I'll see. Okay, we have Christos, we have Judith, we have Daniel, and also we also have other participants in the panel list as well. So we'll go straight to the HMI, what we have. Okay, before we start the HMI proper, I think I did mention earlier, we have a YouTube channel. So if you visit our YouTube channel, you can have a lot of resources in our YouTube channel. So we have different tips and tricks on all our products in the YouTube channel. There are also some smart functions in our products like HMI, PLC. So you also have a video resources in our YouTube channel where you can see how to implement such functions. So there's quite a lot of resources, product information, product function, how to set up the function in our YouTube channel. So we advise you to visit our YouTube channel and subscribe to our channel as well, so that when the video is being published, you will get a notification about the video that has been published. So the range of videos in this channel is quite large, from robotics to other different type of products that we have, codicics. We have videos in the YouTube channel on these products. Also, we also have a download center where you can download our software and manual. Our user manual is very helpful. So if you are new to Delta and you want to know more about our products, the user manual could be very helpful, as well as the software. So if you visit our download center, there you'll find a lot of resources that will help you when you are making your machine. So when you come to the download center, if you click on industrial automation, we have different products, different business group. But if you come to this very business group, industrial automation, and then if you scroll down the page, you have a section that is called the download center. And if you click the download center, it takes you to the download page. In this page, you can download the resources and the materials that you need to make your machine. First, you can download our software. So 99% of our software are free. You don't have to pay any money for our software. I think it's only the SCADA. You need to subscribe, depend on the SCADA package you have taken. So the rest are free. So software for PLC, for HMI, for almost all our products, they are free. So you can download them on this download center. And also the user manual is very helpful. There are some basic functions you want to know how to set. Reading the manual alone, you've already got a tips on how you can set those functions. So we normally advise our customer to try as much as possible to look into our manuals. And there are step-by-step direction in the manual, how you can set up some functions in the products. So like I told you that we have a group of products in Delta we call control products. Some of these products include, you could see on the screen, PLC, programmable logic controller. I think you already had PLC training already. So this product is part of the series of products we call control. So these products, they are grouped into control product because you mainly use them for control application. You also have the touch panel. So that's what we'll be looking at shortly. The HMI, human machine interface, test panel, industrial field bus solutions for CAN open communication protocol, Ethernet communication protocol, device net communication protocol, Modbus TCP. So different kind of field bus solutions. So we have products that will help you to realize communication in the protocol that you prefer. And also we have internet switches, we have PC-based controller. So these products are part of what we call control products. You also have temperature controller. This is more or less like a process controller. You can use this to control your machine, depending on the type of machine that you are making that is temperature sensitive. We have machine vision systems, we have barcode scanner, we have vision sensor. We also have process counter, timer, tachometer, gas flow meter. And then we have industrial power supply as well, power meter to monitor and manage your energy consumption. We also have different type of smart sensors, presence sensor, laser sensors. So they are quite much. So these are the list of products we call control products. And HMI is one of the products in this list, human machine interface. So when you hear the HMI, what comes to your mind? So the first thing that comes to your mind when you hear the HMI is visualization. So for example, if you have this machine over here, and you want to monitor what happens in each of the processes, you want to see different indicator of what is happening in this machine, then you need an HMI, which could be installed locally on this machine to visualize what happens in this machine, maybe the volume level, the gas level, anything you want to monitor. So the HMI is useful. It's handy when you have an application that visualization is very important. And besides visualization, you could also use the HMI as well for control. So you could have a button on this screen, and just clicking on the start button, this machine starts running. So that's the basic use of HMI. I also have this advanced function in our HMI, cloud integrations. So with this function, you can connect your smart device, a smartphone, iPad, iPhone, Android devices, your tablet, to the HMI, and you can remotely control any controller, any devices that is connected to the HMI. In the industrial automation, one of the most used visualization system is HMI, human machine interface. There's also another one is called SCADA. So the difference between SCADA and HMI is quite simple. HMI is mostly local based. It means that on most machines, you install the HMI directly on the machine or very close to the machine. So it's quite accessible, very close to the machine. It's local. And then the other one, which is quite scalable, is SCADA. SCADA is remote. So most time you have SCADA system, because SCADA is also for visualization. You have SCADA system in the machine room. So when you have series of machines, you want to visualize and control them, then you need a SCADA system, which you can have in the machine room. So the difference between a SCADA and HMI is this. HMI is like a rat, a mouse, and SCADA is like an elephant. So that is the difference between HMI and SCADA systems. So you can have HMI inside the SCADA, but you cannot have a SCADA inside an HMI. Just like an elephant can carry the mouse, the rat, but the rat cannot carry an elephant. So that was the basic difference between a SCADA, an HMI system, and a SCADA system. HMI is local based, and SCADA is remote based. We also have a SCADA system, but it's not covered in this very training. So in case you heard hear the word SCADA, maybe you have also used it before in your machine. They are both for visualization and control, just like the HMI would do. Now we'll now go to the series of the type of HMI that we have in Delta. The first low function-based HMI we have is called text panel. And we have different types in this text panel. We call it text panel because this HMI is mainly controlled by buttons. In other words, the screen is not touch sensitive. So it's a text panel. It can only be controlled with a button. For example, if you want to turn on a machine, let me say a pump, and you have connected this pump to this HMI, you can only start that pump when you press one of these buttons. You assign this button to start that pump, but you cannot touch this screen, to control the pump. So that's why we call it text panel. And the sizes are different ranges. Like this very first one, this is the smallest we have, text panel 02, TP02. It means it has only 2 lines of text. We have TPO for 4 lines of text, and the biggest in this series is TPO8. It means 8 lines of text. You can see the screen is quite bigger compared to this. And then the higher level of this text panel we also have is the one that has both HMI and PLC integrated as one system. So you have just one product. Inside there's a PLC, and it also has an HMI function. So the first one in this range is TP04. This is the test panel. And in this range, we have different type. We have different type with different IOs, like this very one. This has 32 inputs and outputs. So the outputs and input we have in the ranges we have differs. We also have some, they have analog inputs and analog outputs. So you can connect 4 to 20 milliamp to it. You can read it, and you can also get 4 to 20 milliamp, 0 to 10 volts from it. We also have the one that has temperature sensor. So you can connect a PT100 or other type of sensor. I think it's mostly PT100 we support. You can connect PT100 temperature sensor directly to this text panel. And then you can measure the temperature, and based on the result, you can control your machine. I also have the one that has load cell. So maybe you have an application where you need to measure weights. So you can connect a load cell sensor to the load cell input on this very text panel. And the last we have in this range is the 7 inches. This one is a touch panel. You could see that there is no button. So the screen is touch sensitive. You can create a button inside, and with that button, you can control the machine. And we also have similar ranges, just like TP04, with the one with temperature sensor, the one with load cell sensor, analog input and analog output in this range. So this is our text panel. This is the ranges we have in the text panel. And then the advanced HMI we have, we call it touch panel. So this touch panel HMI, as you can see, they don't have buttons. So the screen is touch sensitive. You can create a button on it by yourself, and you can know by merely touching the screen, control what happens to your machine. And for this, we have different ranges from the smallest size, 3 inches, all the way to the biggest size, which is 15 inches. 15 inches. And one of the series we have in this is the 100. DOP 100. And then it starts from 3 inches all the way to 15 inches. And we also have another series. Before we had this one, we had this already, is DOPW. So it's the wide series. This one starts from 10 inches all the way to 15 inches, as you can see right here. And we also have others that are not here, like handheld panel, the one you can hold to control robots. You hold it on your hand. It's called tissue pendant. You can hold it in your hand and control your robot, what you want to do. So this is the range of the HMI that we have. To be specific, the touch panel that we have in Delta. And for you to easily select this HMI, we have ordering information. And the models are easy to select. So when you see our HMI, the name looks like what you could see here. So the first group of model name stands for the product name. As you can see, DOP stands for Delta Operation Panel, and this stands for the series. This HMI, we call it W100 series. Like I told you, we also have W series, and just like that. And then this column in the model name is for the size of the HMI. So depending on the size you need for your machine, the size is right here. And then the fourth column in the model name is for the type. So we have different type B all the way to M. As the type differs, so also the prices differs. And the last, meaning in the model name, this column stands for the resolution. This has to do with the quality of the screen of your HMI. So this is how you basically identify a HMI. And if you are ordering, this name rule helps you to choose the right HMI that fits your application. This is just a more detail to what I already showed you in the previous page, the grouping of the HMI. So the HMI, our HMI is, our touch panel, to be specific, is grouped in three hierarchy. The first is basic, like I showed you in the previous page. This basic, it has one COM port. So when we say COM port, it means the physical communication port that you have physically on the HMI. So the basic HMI, they have just one communication port, serial port communication, like this B type. This D type has additional Ethernet port. So you have one COM port plus one Ethernet port in this D type. You also have the next level standard HMI. So this standard HMI, they have at least two communication ports, two serial communication ports. This C type just only has two communication ports, and the E type has two communication ports, serial communication ports, plus an Ethernet port, and the I type has three COM ports plus Ethernet ports. So depending on how many controllers you want to connect your HMI to, then that will also aid you in choosing which of these HMI suits your application best. And then you can go for the one that has the communication port that suits your machine. And then the highest level is what we call the advanced HMI. So this one, they have at least one serial COM port and one Ethernet port included. One serial COM port and at least one Ethernet port included. And this one includes the W type, advanced narrow frame. So this one, the frame is narrower, so the screen is wider compared to the one that is not W type. So this one, the advantage of this screen is narrower, so you have a kind of bigger display compared to the type that's not W type. And then we also have the M type. This is called advanced multimedia. So this one supports video, supports a camera. You can connect your camera to it. You can have a video in SD card, in USB card, slotting the video to this HMI, and you can play it. But in this case, you cannot do that. So only this series supports multimedia. And then there are some specifications for our HMI, especially for the 3 to 10 inches in sizes of HMI and the 12 to 15 inches. So the 12 to 15 inches, most times they contain advanced function compared to 3 to 10 inches. So these are the hardware differences you can notice in this HMI. First, the microprocessor, the speed. Like the 3 to 10 inches HMI, the speed is quite fast 800 megahertz. But the bigger sizes is dual core 1 gigahertz, so it's quite fast. And also the flash ROM, the memory size. So where if you are writing the program of your machine, where the program is saved, the size for 3 to 10 inches is 250 megabytes. It's big, but it's quite small compared to the 12 to 15 inches, which is 8 gigabytes. This is quite big. So it means this, you can really have a lot of screen, unlimited screens you can have compared to this flash, to this 3 to 10 inches that has just 256 megabytes. You also have the RAM. The RAM is where your memory is saved temporarily. So the size for the RAM for these 3 to 10 inches is 512 megabytes, and for this the 12 to 15 inches is 1 gigabyte. So like the RAM, if you have a value in this RAM area, if you power off the HMI, the value will be lost. So it's just a temporary storage of your machine data. So this is the temporary storage. But in the case of the flash ROM, the flash ROM store your program, the application you have written, and also your large data. So your large data are those data in the last register. If you off the HMI and you on it again, you still have that data. It's not deleted. And the type of touch is resistive touch, so it's quite sensitive, and the longevity is quite high, 10 million press time. So it's quite durable, so you can use it for years and the HMI will still be running. There's also a real-time clock built in this HMI, both of them. The cooling is air cooling. The waterproof level is IP65, so you can always use this indoor. You cannot use it outside under the rain. And the power supply is 24 volts. And you can operate from 0 degrees Celsius up to 50 degrees Celsius. So talking about communication protocols. So what are the communication protocols you can use to control your machine from our HMI? So one of the communication protocol is Modbus TCP/IP. So Modbus TCP/IP is Ethernet-based protocol that is owned by Modbus. So I think virtually every controller on the market support Modbus. So with this HMI, you can connect to any controller in the automation market and use Modbus TCP/IP to control those controller. And then on top of the basic Modbus, we also have Ethernet IP. So this is a different protocol entirely. So in this protocol, our HMI supports Delta, Ale-Brandley, that's AB. It's also Rockwell Automation, if I'm not mistaken, and also Omron. So with Ethernet IP, you can communicate or control this brand of controller, these 3 brands of controller. So I think as we keep on developing, so the ranges of controller we support that supports our Ethernet IP or that we support using Ethernet IP will increase. And then the other possibility is the serial communication. So this one is also based on Modbus. So Modbus is like one of the widely used communication protocol in industrial automation. So with Modbus, you can connect several devices to the HMI. You can also control these devices from the HMI, servo drive, PLCs, and inverter, variable frequency drive. And why the HMI is quite easy to program or very flexible. So you can, communicate with both protocols at the same time. As you can see, this is a different port for Ethernet. There's a port at the back of the HMI for serial communication. And for the Ethernet, you can, connect up to 16 PLC, you see, and this HMI will control the 16 PLC at the same time. If you use a switch, you can connect to up to 16 PLCs using Ethernet communication. And also for the Modbus, if the HMI is the Modbus master, you can have up to 32 slaves. So the HMI is quite robust, and it can do a lot for you when it comes to your machine in your factory. And also the wiring of the HMI is quite simple. In terms of programming, you can program the HMI with different cable. So virtually every port on the HMI can be used to program the HMI. In other words, if you have written your application for your machine, you can use any of these ports to download to the HMI. If you have Ethernet ports on the HMI, you can use Ethernet cable to download. Also, if besides downloading with just Ethernet cable, if you also have an Ethernet controller, maybe a PLC that uses Ethernet, you can also use Ethernet cable to communicate with the PLC. With USB stick, you can copy your program in USB stick, insert it, download the program from USB stick to the HMI. If you have this kind of a USB B type, it's a slave USB cable, you can also use it to program the HMI. And for different controller, different type of PLCs, there are different cable, RS-232 cables for different PLC, AS300 PLC. I think you had this one yesterday for those of you that were in the training, and other controller as well. So we have specific cable depending on the controller you want to communicate with. For the Ethernet cable, is quite generic. So you can buy Ethernet cable from us, but you can use your Ethernet cable to also communicate with controller that supports Ethernet. So for the cables, you can use Ethernet cable, serial communication cable, and USB type cable. And then for the RS-485, it's quite flexible. We don't have a specific cable for RS-485 because it's a very flexible communication protocol. So you can make your own cable. So basically for RS-485, to make your cable, you just need at least 2 cables, positive and negative. Sometimes you have ground to remove noise. So with just the 2 cables, and you get your own connector from the market, so you can make your own RS-485 cable. So we do not make this cable, but we have a pin mapping of this DB9 pins you can use to make your own cable. So depending on the connection you want to make, is quite flexible. You can use this guide to choose your connections. You can use mode 1 communication, mode 2, mode 3. So each mode is defined by the type of pin you use. So when you connect the correct pin in each of the modes, like RS-485, RS-485, then you can communicate with the controller that you want to communicate with using RS-5 communication protocol. So we have several functions in the HMI. So that's why the HMI is also quite helpful in your application. So one of the functions that could help in your machine is alarm. So alarm function allows user to easily manage machine operations and quickly eliminate problem. So with this alarm function, you can set up some registers. You are monitoring the value of the register. Maybe it's a word register. So if the value in that register is maybe a set point, specific value, you can trigger an alarm. Maybe it's also a bit register. So maybe if the state of that bit register changes from high to low, from low to high, you can trigger an alarm. And when you trigger an alarm, you can also send an email to yourself or to any email based on the alarm that has been triggered. And on the HMI, you can display the alarm message and also attach the screen of the alarm in the email. So when you have a system that is very critical, you want to monitor what happens. So this function could be handy for your machine. So what you just do in the HMI software, you enable this function and the alarm will be ready. We also have another functions for data management. One of them is historical data. So what this data does, it helps you to keep record of some registers you want to monitor on the machine. Maybe there are some registers that are maybe temperature sensitive, pressure sensitive, or the speed of a drive sensitive. And you want to monitor the value in those registers. So what you have to do is just set up an historical setup that records the data in those registers, and those records will be saved in an Excel file. And you can also stamp the time and date where those data were recorded, and then you can retrieve those data from the SD card or USB stick. You can also use to maybe plot graph, analyze what has happened to that very data for the time being. So this also depends on your machine. So there are some machines that are very data critical and sensitive. So the factory wants to know what happened in that specific register. So what they can do is to set up this function that will always record the data in those registers, and you have it on an Excel file. Another data management function we have is recipe. Recipe is also a more convenient way to manage data, especially in factories when you are producing different kind of products, but the process is the same. For example, let's say you are making cake, and the cake is just one machine, maybe the same speed in the machine, but you want to make different type of cake. Then this recipe function will be very handy. You just set up recipe for each cake, maybe recipe for cake 1, it's a strawberry cake. Then you can set up, okay, how many strawberry? Strawberry is 300, chocolate is 0, vanilla is 0. So this recipe value will be updated and fed to your controller from the HMI. Maybe the second recipe is a cake. You want to make cake recipe 2. It's chocolate. So how many strawberry are you going to use? Is 0. How many chocolate? It's 300 grams of chocolate. Vanilla, how many? 0. So you set up the recipe for this, and this HMI will feed it to your controller. So what happens is that you make different products from one same machine. For example, let's say, okay, it's also a bread making machine. You make different bread sizes, but you want to tell the machine that, oh, the bread size that is to be made now is this size, is this size. So then you need to set up a recipe, and the HMI will feed this data to the processing machine. And then you can have a very more flexible system. And also you can save this recipe on an SD card, a USB stick, and this data is always recorded or written in the SF file, so you can retrieve it, you can update it and upload it to the HMI. There's also another function you can use remotely to monitor the recipe data. This is quite handy in a processing machine production when you need to use a particular machine to produce different products. Then you can easily do this with recipe. And then we have another function for data management. It's called PDF function. So this PDF, if you set up this PDF elements, you can be able to read PDF from the HMI. So you can read PDF, you can read text file using this function in the HMI. So maybe, for example, you forgot your PC in the factory and you have already set up this element on your HMI. So you can just insert your USB stick and then select the file you want to read. Like this, you can see now this is our manual. Somebody is reading the manual using the HMI. So with this PDF elements, you can read PDF files. And then we also have another function, multi-language input. So we support 16 languages. So if you want to maybe set a password, a specific password with a different language like Arabic, Chinese character, so then this multi-language input function or button is very handy. Then you can make choice of different languages you want to use to enter some specific character into the HMI. We also have user authority management. So if you want to secure the operation of your HMI, you don't just want anybody to just get to your HMI and start using it. So you can create different accounts and password. So maybe you have different users in the factory, you create their name and you create their password. So if they want to enter your machine, if they click any button, so there will be a security prompt up window that will ask them to sign in. So they will put in their account name and the password. So if they don't have the one that you have set, so it means the person is an intruder, so he cannot get into your HMI. And it's also possible to monitor who has logged into the machine at a particular time and what the person did on the machine. So this is for security purpose, password and account. You also have another function, it's called operation log. So this operation log, it helps to monitor the operation of the HMI. So the elements that were used, the address that we visited, the value that we set in those address, so you can have all of them recorded if you enable this operation log function. For example, look at this very user manager. This manager came into this HMI. He visited screen 1. He pressed another screen element. He did not set any address. So the value was 1. He changed the value to 10. I think this one, let's go to this one. The same manager, he went to screen 10. He pressed this button, set value button, and it writes to the address in that button. The value was 1 before. Now it off this address. This address is a bit register. It was on before, but it changed it to off. So this operation log helps you to monitor who has used the HMI and what the person did on that HMI and at what time the person operated the HMI. So you can all be able to trace, maybe somebody came to the HMI, operate the HMI, and the HMI is broken. You can trace who is the person in the factory that used the HMI and the HMI got broken or the system began to malfunction. So that's the operation log. So all these functions that I've just mentioned, they are only in operation when you enable them. So if you don't enable them in the HMI, so they will not be functioning. So you enable them, then they start functioning. You can use them. So another function we also have again is this lower language programming. So this is a new feature in our HMI. So besides the way we have for programming the HMI before, we now gave a more flexible way in addition to what we have before, another way you can program your HMI. So this one gives you a more programming area where you can write what happens in the HMI based on your operation. For example, maybe you want to press a particular button, and if you press that button, you want a specific action to take place. So you can come to this programming area, write the instruction you want, and when the function is met, so what you have written will be executed. So we call it lower program language. Another function we also have again is multimedia. So this function is specific to the M-type HMI only. So this multimedia HMI, you can connect different camera to them, analog camera, IP camera. So you can also use a surveillance camera to capture whatsoever that goes around the factory. So you can capture image based on a specific action that happens. You can trigger the video or the camera function based on event. You can capture image with an external camera or replay important recording. So besides just having your camera here, you can also play video file in this HMI. Maybe you have a video on SD card. So just load in the SD card or USB stick, and then you can play the video, or the video can play automatically based on what your preference, what you want. And this type of HMI, they are very useful in different applications like packaging application. You want to see what is happening. Logistics application, you want to monitor the movement in the logistics environment, in mining, power generation, oil and gas, textile, pharmaceutical, rubber, and plastic. So these are applications that are very vision sensitive. You want to see what is happening. So this type of HMI, M-type, is very useful for that kind of application. Another function we have again, these are the cloud functions. So when we say cloud function, they are the function you have access to via internet. So they support internet. So like one of them is FTP server. So what this function does in the HMI, if you enable this function, it will give you the possibility to remotely get access to the files in the HMI. So if you have a USB stick on this HMI, you have an SD card on this HMI, and you want to get those files from the USB stick, all you have to do is be on the same network in your PC with this HMI, and you can remotely, so then you don't have to come physically to this USB stick. Remotely from your PC, you connect into the USB stick and get the files that is in this HMI. Of course, it's also security based. So for you to log in to this HMI and get the files in the USB stick, you need to enter the password. You need to enter the IP address of the HMI. So when you know the IP address of the HMI and you know the FTP password that have been set up, then you can log in and get all those files. You can get PDF files from the HMI, get recipe file from the HMI, get the history file, the operation log file, the alarm file from the HMI. And also maybe in your office, you have Wi-Fi. This one is on internet, and that internet is broadcasted wirelessly to your PC. So wirelessly, you just connect to this HMI and get all this data from the memory, external storage, USB stick, SD card on this very HMI. So this is called FTP server. We also have another cloud function called VNC server. So this VNC server, it gives you access for you to remotely control the HMI. So, and we have different VNC client app or viewer for Windows. So if you install VNC viewer in your Windows, your desktop, if you log into this HMI, you have all the screen in the HMI right away on your PC. If you are using iOS, iPhone, iPad, any devices, smart devices that has to do with iOS system, you can also use it to control the HMI. So if you log in via this VNC server, you can control all the screens in the HMI. So what happens with this function is that you will have a virtual HMI on these devices. So everything you can do on this physical HMI, you can do it on these devices you are using, as well as Android is also supported. So if you have Samsung Galaxy, iPad, so you can use it to control the screen. So when you change the screen here, the screen will be changed here. If you press any button of the HMI that is on this virtual device, the same effect will take place on the real HMI. And also one of the limitations of this, you have to be on the same network. So for example, now, where you are connected from your country, if I have an HMI here, if you cannot from your country control, I cannot, okay, let me say I have one of these devices here and you have HMI in your factory. I cannot from here control your HMI. Why? Because I'm not on the same internet network. So my device has to be on your network for me to be able to control your HMI. So another function we also have for the cloud integration is eServer. All the functions I've mentioned since, they are all inside the HMI, but this one is an external software. It's just like a data collection software. So if you need to like regularly collect data from your HMI and log it to an Excel file, then you can use this eServer. So the eServer will be running on your PC, and then it collects the data from all the HMI you have set in this software to collect data. So it's like a database collection software. It helps you to collect and record data from the HMI. And this data, they will be saved in CSV file, Excel file. Another function we also have again for cloud integration is web monitoring. This web monitoring, what it does, it gives you the possibility for you to access the HMI from your browser. Maybe your browser, you have Internet Explorer, you have Google Chrome, you have Opera. So it depends on what your browser could be. You can use this web monitoring function to access the HMI. So this function is limited to only the register you have set up to monitor. So inside the HMI software, you create registers you want to monitor. And once you have created those registers, if you log into the HMI with the IP address and the password, you can see those registers you have set up, and then you can write them. You can also read and see the value in those registers. This function is like other functions. You need to enable it in the HMI. So once you enable it, then you have access to use your browser to monitor some values, some data in the HMI. Then you also have another function again we call OPC server. So OPC is just like an open communication protocol that is widely supported in industrial automation. So if there are SCADA systems, SCADA clients, you can use the OPC server in the HMI to connect to the client. And then once the client has access to the HMI, then every other machines you connect to the HMI can be controlled from the client OPC. Maybe you have pump, you have different kind of application, different kind of controller. They are connected to this HMI, and you want to control them. Then you just use this OPC, which is TCP based, to connect to those SCADA clients or OPC client. Then you can control all the devices on the HMI. So that's for the HMI. So this is just like an introduction about our HMI. Now we now have just an overview of how you program the HMI. And then I'll also take you through the software. We see how you can use the software to program the HMI in a very easy way. So I think amongst different controllers in industrial automation, HMI is like the simplest to be programmed because it's very easy. The software we use to program our HMI is called DOPSoft. So Data Operation Panel Software, DOPSoft. And like I think I mentioned before, you can use different cables to program the HMI. So depending on the ports at the back of the HMI, you can use different cable to program. And we have different cable from the HMI to program the HMI. And there are some cable that are very generic, like Ethernet is generic. So you can get any Ethernet cable from anywhere and use it to program your HMI. So in the HMI, there are different elements you can really use to make your machine very interactive. So I think one of the features that customer likes about the HMI is what you see. Since it's a visualizing system, so people like to see something that is very interactive, something that is very simple, that is smart. So inside the HMI, you have different elements that you can use to program your HMI. And besides the one we provided in our HMI, you can also download your own from the internet and also add it to the list. So you can use any elements to represent your machines, your application in the HMI. So why is it very easy to program the HMI? It is easy to program the HMI because HMI itself, it has memory. So like the symbol we give to the memory of the HMI, of our HMI, one of the register is denoted with this symbol, $sign. Maybe other manufacturers, Siemens or Rockwell, ABB, they can give their own another sign, but the symbol for one of the word registers we have in our HMI is $. So we will see later, if you want to choose the internal memory, you will see this inside the HMI software. So HMI has its own internal memory, so you can use this to do a lot. I think we have up to 65,000 of this register. This one is a word register, so it's 16-bit register. I will also have in the HMI as well, other internal memory denoted with this symbol, $M. This one is a non-volatile. So it means that if you have data in this register and somehow the power of the HMI got interrupted or you shut down the HMI, if you power up the HMI again, the value in this register will still be there. But in this case, the value there will be erased. You also have this, it's like a pointer indirect addressing register. And also the last group of internal memory of the HMI we have is internal parameter. So we have different internal parameter for the HMI. One of them is USB status. So if you read this memory, this parameter, it reads the status of the USB port on your HMI. So if you plug a USB stick on the HMI, this register will turn to 1 if you are reading it. If you remove the USB stick, the value in this register will turn to 0. So we have several other internal parameters that you can use to monitor some things in your HMI. So this is one aspect of the memory of the HMI. This is its own internal memory. And then why is this also easy for HMI to control other devices? Is because other devices in industrial automation, they are address-based. So the HMI can control external addresses of controller. So like this PLC, we have addresses for this PLC. You can see like these are extension module for the PLC. Output module, input module. Each of these modules, each of the ports, the IOs in this extension module has a specific register. So for example, if I connect a light bulb on one of these ports, that light bulb, if I want to turn it on, I'll go to the HMI program and set the state of that register on this place to on. You see that light bulb will go on. So that's why industrial automation products are easy to program because they have their own internal memory. Like also this is VFD, variable frequency drive. So this one has also its own address. There's an address for the speed if you want to set the speed. So just write the address, the speed address from the HMI. Immediately you will see the speed, you start running in the speed that you have chosen. The same applies to this drive. So there's an address for the speed, an address for the start, address for stop. So when you reference the addresses of external controller in the HMI, immediately this controller will be controlled and monitored by the HMI. So one of the ways we program our HMI is with elements. We have basic elements in the HMI. So elements include buttons, meter, bar, pipes, display. There are very many. So for example, this is a button element. So if you just create a button, you just drag it, draw it like a rectangle, you have a button. So this button
Victor, we cannot hear you. Victor, I'm not sure if I'm the only one cannot hear you.
Can you hear me? Ufu, can you hear me?
Yes, now I can hear you.
Hello, can you hear me now?
Victor, I can hear you, yes.
Can you hear me? Can you hear me?
Victor? Yes, I can hear you.
And me, can I hear you?
Hello, can you hear me? You can hear me, right? Kufu, can you hear me?
Yes, yes, Victor, we can hear you. But it seems you
Can you
cannot
hear
hear
me?
us.
Oh, you can hear me now? Okay,
Yes.
good. Yes. Yeah, sorry, it seems the internet is not stable. So one of the way you program the HMI is with elements. So if you draw this button element, so to control this product, just reference the address of the variable you want to control inside this product. For example, you want to control the speed. So in this address register, there's a speed address. So just register the speed address. And then if you click on this button, any value you write on this button will go straight to this device you want to control. So this is what I've just illustrated. So reference the elements to the button, and then right away, you don't need to write any code. Just any value you write on the button will be reflected on the device you want to control. So another way you program our HMI is through macro commands. So macro are type of instructions you can write, and those instructions will be executed. So we have different kind of macro command for arithmetic operation, logical operation. There are very many. And we also have a macro wizard that you can use to write the correct syntax. So every instruction you write on the macro area will be executed. So this is the second way you can program our HMI. The first is with element. The second is with macro. And we have different type of macro. So these are different commands. We have macro types. For example, for buttons, you have the on macro. So assuming this is a button, assume this is a button. If the button is on, if it is in the on state, for example, every macro you write in the on macro area will be executed. If it's off, the macro will be executed. So different type of macro. When the screen is open, you can write a macro. Based on the clock of the HMI, you can write a macro. Background macro, when the HMI is operating, so to be executing on the background of the HMI. So these are the different macros that we have. So on each element, there's a macro area you can write your instructions, and those instructions will be executed. So the third way, so this is the last way you can program our HMI, is through the lower language programming. So it's quite similar to the macro, just the difference is that you write this in a different area. So there's an area we create on the HMI that you can write your lower code instruction. So this software programming type is just based on instruction. So based on your instruction you have written, the HMI will control your application. So now we are going to do some basic exercises. I'll just take you through our software. And if you have a question, I think after this programming section, we'll just handle question and answer section. So like we discussed earlier, so the HMI you can program with different communication protocol, with Ethernet, with RS485, and you can, with Ethernet, you can control up to 16 devices, 16 PLC. At the same time, one PLC is controlling pump, another PLC is controlling milling, another PLC is controlling packaging. So there's no restriction to what you can do on the HMI. And for RS485, if this is a master, you can have up to 32 slaves that it controls. So now I'm going to share my screen desktop with you. Then we just go through the software. And then after the software section, we'll just take a time for question and answer. Okay. I hope you can see my desktop. Let me share again. Okay, I think you can see already. So this is my desktop. I want to open up the software. So the software is called DubSoft. Okay, yeah, thank you very much. So if you open the software, DubSoft. So the software for programming our new series HMI, which is Dub 100, is DubSoft 4. So I will just open this. So if you also want to like just play with your software at your end, you could also play with it. So once you open the software, you just create file, new project, new, and then you choose the type of HMI that you want to program. If I choose like WX, this is 12 inches, and then you click next, then you can name it, you can give it a name, let me say packaging machine. So you could click next, then you set up your communication. Once you have set up your communication, you click finish. You see this HMI that I've chosen, I choose a 12 inches HMI. So this port you are seeing here, it means that at the back of this HMI, you have all this port. You have COM1. COM1, it supports RS232, RS485. You have COM2, physical ports. You have COM3, you have COM4. This HMI is really quite big. And you have Ethernet port 1, Ethernet port 2. And these ports, they are different, so they are not connected. So you can connect different devices on this, connect different devices on this as well. So each Ethernet port can take up to 16 controller. So this one can take 16 PLC, 16, whatever the controller might be that support internet, so you can create on it. So if you choose the port, you set the communication like this. So you set the protocol for the other device. Also, as well as this. Now, this is not enabled, but you can enable for Ethernet. You just click Ethernet, then you can add a link. Then you select which Ethernet device you want to communicate with. Now, this is Delta. You can scroll down to other devices, Ale Brandley, Beckhoff, Schneider, Mitsubishi, Fuji Electric. So these are different controller that Modbus you can set up. For example, if I choose Modbus, which of the Modbus TCP IP. So this is the address of the Modbus device master. And then you can also come and set the IP address of the HMI itself. So once you have set it of the HMI, then the HMI can communicate with the other device. So this is communication settings. But if I didn't want to come here, I could already stop at finish at this first page and click finish. So if I click finish, I could also go to options and go to the communication settings. That was where I just showed you that you can make the setup. So good. So what we'll do is this is the programming interface of the HMI software. You have the file, you have edit, you have the view. So the view is where you control what you want to see in the tab. You have the screen. So from the screen, you can create new screen. And also a shortcut of some function is also here. So the screen here, what the screen here will do, you can also do it from the screen here. You right click, new screen. Then you have tools. Tools, you have compile all. Here you can download what you want to download. You have online simulation. Online simulation is when you don't have our HMI with you, but you have the controller. Assuming you want to use a Siemens controller. You have a Siemens PLC, but you have not yet bought Delta HMI. But you really want to see how would the control be. Then you use the online simulation. So if you execute this, you have a virtual HMI on your screen. And then you can use that screen to control the Siemens PLC. You also have the offline simulation. So the offline simulation, you want to just simulate your program and see how it behaves. but it's not connected to any controller. You execute it. We are going to do it shortly, and then the online simulation will be executed. Also, firmware update, you can update the firmware of the HMI. Then you have options. So in options, this is where you have those functions I mentioned to you. So this is where you set up the functions. So there are very many. Depending on your machine, you set up those functions. If you go to options and you go to environment. So in this environment, this is where you choose how do you want to download your program when you are finished programming. Do you have a USB cable? Select USB. You have an Ethernet cable. You have a serial cable. Depending on the port on the HMI, so just select the way of programming the HMI. You see upload, download, and then you can use those cable to program the HMI. So these elements, buttons, there are very many. You also have a shortcut of them here, a quick tab menu where you can easily access them. We have many elements. There are so many. You have buttons, different type of buttons. So once you create this button, any address of the controller you reference on this button will be controlled immediately. For example, you want to press a button to go to different screen, like this go to screen buttons will take you to other screens. So there are very many. And then for the function setup, if you come to, today we spoke about alarm. If you want to set up alarm to monitor the operation in the factory, this is where you do the alarm setting. If you click on it, it brings you to the alarm page. You can set the message, which register you want to monitor, and just like that. You also have options for the history buffer. There's a particular registers, you want to get data from them frequently and save it in an Excel file. If you set up this function history buffer, you set it up, then you have it ready. So the functions in the HMI, it's only when they are enabled that they are in operation. So if you don't enable them, nothing will happen. Maybe you want to print from the HMI, you set up your printer. So there are very many. And then if operation log, I told you about operation log. You want to monitor the people that use your HMI. If you enable this and set it up, you can monitor the time the person came, the user, who is the person that came, which password level does the person have, which screen did the person visited, what was the person action, which button did they press, which address is in that button. Is it the address that control your pump application, that control the lights, just like that? And what was the value when the person came, and what was the value the person changed it to? So you monitor the operation of your HMI with this operation log settings, options, operation log setting. Now I told us recipe. If you need to create a recipe to monitor production, to facilitate production, you have a machine, just one machine, and that machine produces different products. Then you need a recipe. So from this recipe function, you can update the HMI. The HMI updates the processing machine, which products should be produced at a particular point in time, and what are the recipe and the quantity of those products. So if you enable it, you will have it, the function running. You have picture bank. Like I told us, there are different pictures on the HMI, different elements on the HMI. On this place, you can put your own picture bank. I think there was a time I went to the internet, I downloaded some fruits, apple, different fruits, and then other fruits. So I just install it. So you can make a picture of your factory, a picture of your machine, and put it here. Then you can use it inside the HMI. And then if you go to options, configuration. So this is where you do some advanced setting, configuration. If you come to configuration, then you can have more advanced setting. I think I told you about FTP. You want to like remotely get data from the USB stick on the HMI, you enable it. Multi-language settings. And then you have a network app. See network app, remote desktop collection, VNC. If you want to use your Android, your tablets to control the HMI, if you enable this function, and you install the VNC on your smartphone, you can control the HMI. All the screens on your HMI will be virtual on your smart device that you can control. So there are many functions on the HMI, and depending on what you want, you enable them, and then it will help your machine to be very efficient. And also there are other advanced functions. So when you go through our HMI, you have more, you'll know more about this. This real-time monitoring, I told us about this. You want to use your browser, Explorer, Google Chrome, Opera, to monitor some address in the HMI. So just set up those addresses. What is the value? Is the speed of the pump, the state of the lights. I want to delete them. Then if you go to your browser, you can see the value there. So this is an overview of the functions. From the HMI manual, you can really get step by step how you execute this function. And if you have some questions, you can contact Ming or one of our sales manager. They will refer you to our technical support system. You can send your email, and then you can get support from our specialist. I think I also told you about another way to program the HMI, which is macro. So we have different type of macro. You see, this is clock macro. This clock macro, it would execute based on the clock of the HMI. So any instruction, any code that you set on this macro will be executed. You have background macro. While the HMI is running, it's just operating on the background. Initial macro, the first time you power up the HMI, all the instruction you have written will be executed. So different type of macro you have. For example, let me create a button. If I create a button, to create a button, you can come to Element, Button. Let me go to screen. Element, Button. Let me create Maintained. So there are different type of button. Maintained means if you press it, it remains on state. If you press it again, it goes to the off state. Momentary is just like if you press, it goes back by itself to the on state. Let me create maintain button. See maintained. This is the button. So this button, if you come to this button, which address do I want to write with this button? So let me write the internal memory of the HMI. You click these three inputs, these three dots. Then you come to internal memory. So this is what the $sign I told you. So we have $sign and $hem. I choose $10. So you can see this button only support bit elements, bit address. So you can only use bit. So to reference bit in our in the register of the HMI, you have .5. .5 means bit 5. So this register $10 is a 16-bit register, but I want to change the state of bit 5 of this register. You see bit 5, so enter. You can see it's here. I also want to read it. I'm writing, I want to read. So if I copy, can just paste it to save time, paste. So it means I read, I write, I read. And then this is the state of the button. So when the state is 0, it means if I have not pressed the button, what would happen? Then I want to, what do I want to see? Do I want to see text? If I want to see text, you put text, this text will be shown, but I want to see picture. So when the state is 0, I want to see picture. So go to picture, picture bank. For example, if I want to choose the picture I created, like I told you earlier, I will choose this, but I will choose this later, not now. But let me choose from the picture inside the HMI buttons. So we have different elements you can choose from button. Let me look for button, 3D button, 3D toggle switch 2 state. This is a type of switch. This is another switch again, toggle switch 8 state. So the switch you choose depend on what you want. 3D, this is 3D toggle switch. Okay, I want to choose this. So if it is off, yeah, if you have already programmed our HMI before, sorry, you just have to be patient. I know this is quite very basic, but for those that are new, if you have not programmed our HMI before, this could be interesting. But if you have been a programmer for HMI, so just be very patient. I will soon round up these sections and then we'll go to question and answer. So then I can use this to remove the black. You see there's a black background behind. I want to remove it. I'll remove it. Which side? 1:1. And then, so when it's off, I want this one to display. And when it's on, state 1, then I have to choose another picture again. 3D button again. 3D to state. This is another type of button. So you only have numerous buttons you can choose for. 3D toggle switch. Okay. I want to choose that it's on. Green. It's on. So I want this to appear. Ratio 1. So you see, if I click OK, yeah, before I click OK, come to macro. You see, if you click macro, this was what I was expecting. Before I click this button, any instruction that I write here will be executed. If I write any instruction here, that instruction will be executed. After I've pressed the button, any instruction I write here, they will be executed. On macro, it means if the button is on, what I want to happen. You understand? So if the button is, I can say, if it's on, just increase a value by 1, just like that. If the button is off, write your instructions here. It will be executed. I click OK. You see, I've clicked OK. I can still see this background beside. I don't want to see the background. I can just double click and come to style. Look at style. I want it to be invisible. If invisible, then you will not see the background anymore. So you only see a button on the HMI. So this is one of the way you program the HMI and the elements. So once you click on this button, immediately you can see the state of that bit will be on. For example, if I put let's put an indicator here. It's $5, right? An indicator, like, come to element, you can see indicator, multi-state indicator. It's also here, there's a shortcut, it's the same as this. If I come to this indicator, so indicator is just monitoring the state of the address you are reading. Which address I want to monitor? I want to monitor that same address, internal memory, bit, address 10, bit 5, the state, enter. Good. So now, if we go to the picture, I want to see a lamp. For example, 2-state 3D fine lamp. Can go to picture. Yeah, sorry if I'm too fast for some of us, maybe they are not used to. Okay, this one is a lamp. Okay, let me put this red. So when that address is 0, this one will be displayed. I remove the black background. And then the style, when it's off, when it's on, when that bit state is on. So what will happen? So let me choose another picture again. 3D, another type of lamp. 3D 2-state lamp. It's another type of lamp. 3D 2-state lamp. Okay, another modern lamp, modern pump. So there are very many, and you can also download what you want to see by yourself and put it 3D lights. So this is another light, something like this. Can remove the black background. Okay. The style, I don't want it to be visible. If I click OK, see, we are seeing the background, but I want it to be invisible. This picture, I remove this, the white background, the black background behind it. And then style, go to main 2, main 1, style. The style, I want the style to be invisible, style invisible. So it only shows the element. Okay, you see, you have it now. So now this, I told you about offline simulation. This offline simulation. So I want to see how what I've just made now, how it behaves. It's offline simulation. So This one is going to create a virtual HMI on my laptop for me. Then you see the HMI is going to appear. So now it appears. So if I click this, you see, it turns on immediately. I didn't write any code, nothing. So if this was a pump address of a controller, immediately you trigger this and you link it to that address, the control will take place. That's why the HMI is very simple to program. I didn't write anything. This button automatically done this for me. So you see, it changes the state. I'm turning it on, off. This is just an indicator to show the state of that register. But this button is switching that state for me. So that's for that. Then I told us about macro. To program, let's just make small program to round up this section. So we are almost through. If you go to display, this is display. It's also in the element. Display, data display. I want to display a value. So let me put something like calculator here, value. So this one is here. You can see this. So this is display. For you to set up this display, you can double click like I've been doing, or you can go to your right hand side. Here you see the properties. I want to change the color, background color to white. You see it has changed to white. The text, the font to very big size, font 72. The color to red color. And then this border that is here, let me leave it, but you could also change the color. So which address do I want to display its value? Internal memory address, $100. Okay, so I've entered it. So you see this address, $100 will be displayed here. Now, why this is counting, I just want to put a sort of fancy picture here. Let me put an indicator. Indicator, come to indicator, multi-state. Then go to picture, multi-state. I want to monitor the state of this, the address in this button before. It was bit 5 of $10. $10, bit 5, bit 5. Bit 5, okay, it's ready. And then I want to put picture. So let me go to the picture that I told you I downloaded, and I put, you can also download the picture of your factory of anything. So I put this, so if it's off, you see this picture, 1:1. There's no background. Okay, and then if it's on, I want to see the other picture, go to fruit again. I put this. So this could represent anything, but this is just for text. Actual size is 1:1. And then I want this tie to be invisible. So I don't want to see this background around it. Invisible. So now it's ready. So if I press this button, it will change. You see the other fruit that is here. And then let's write a macro command to just count a value. So the value here is, the register here is $100. The bit here is 10.5. So let's write a macro command. So you could also write a macro command here. Come to buttons, I double click, macro. If it is on, if I press it, what I want to happen, I can write the instruction here. But I want to write clock macro, options, clock macro. So based on the clock of the HMI, what I've written here will be executed. So our instruction is if bit 5 of that address, if it is pressed, if it is on, then, so if you don't know how to write this macro, there's a macro wizard here. You can use this one, input, address, $ is internal memory. Sorry if I'm too fast, $100. So that's the value in this display. You see, it has entered input. You see, it has entered $100. equals, yeah, you can copy and paste it, $100 plus 2. Okay, it's there. So now it's counting 2. So if it's the value is up to, let me say 200, the hundreds, for example, it should start from 0. If this value is greater than equals, let me say 200. Let me see. And then what do I want to do? I want to restart from 0 again. So this could also be a machine application. So what your instruction controls depends on what your machine does. This is just an example. That's why I'm just using this 0. And then we end our instruction. End if. And if. Okay. Okay. Okay, this instruction I've written. If you just click clock, it will be there. So now if you come to option, clock macro we just wrote now, you see the instruction is here. So this could be a series of instructions that controls the operation of your machine. So let's just simulate this and let's see what happens. So if you offline simulation, so it gives us a virtual HMI, and then so it come up. So when it comes up, you have a virtual HMI that represents what you have already made, and you can just have a feeling of how the machine works. So it takes quite some time. You see, it's counting. It's counting. Stop. So this could also be the operation of your machine. If you turn this on, your pump should start running. You turn on the lights. So what you do with man code instruction, it depends on what your machine is doing. So, and that, once you program the very address of the element or the device you are programming, your machine works fine. I think if you could remember, I told us about lower program. So what you have just done now, clock macro, you see. Another way you could also do this is through what we call the program. So if you come to the main, it opens up. So what I've done there, I could also do it here. And you can create different hierarchical program. You can create program, add, let's say you have add one. This one is packaging. This one, so this one is for packaging. This one is for milling. So there's no limitation to what you can create. So all the instruction you write here, if the condition is met, to be executed. So you have 3 ways to program a HMI: through element, through macro. We just did macro. There are many macros, there are screen macros, and through lower program. So that is all for today. So thank you for your time and your patience. Now we are going to have our question and answer sections. So does anyone amongst us have questions before we have a pool of the feedback? Just a moment. Let me share my PowerPoint. So do we have any question from the audience, please? Okay, let me see. Okay, if there's no question, so it means, yeah, it's understood. I think if you have been programming with our HMI, I think the session I've been taking us through for you, some of you is quite boring. And for some of you, if you are just new to our HMI, so maybe I was quite fast, but that's just the general idea of how you program our HMI. So do we have any question, please? Then if we don't have any question, I will just send us the pool to just give your feedback on this course, on this section. So your feedback will help us to improve the content of our training. Maybe there's something you expected you didn't receive from the training. So when you give your feedback, so we can get back. Oh, I can see there's somebody raising hand. Okay, Olango, hello, thank you. Yes, okay, yeah. Yes, thank you very much, Olango. I think our marketing department, so your question is about another training. Yes, our marketing department, from time to time, they schedule HMI training. So I think in next week or 2 weeks' time, we're also having another HMI training. So because this is online training, we cannot really practice with a real HMI, you understand? Okay. Ufuk, you want to talk? Go ahead, Ufuk. Okay. So our marketing will send you a meeting outline that we have regularly. You can join. So just that for this HMI, it's more of basic training, and we have other product training as well. I think tomorrow we have other training, and this week and also next week, and just like that. So I don't know how you were invited to this training. Maybe it's through Ming or directly from our marketing department. You can easily also get access to them. Okay, another question again. Exactly, yes. You can program the DOP to control egg incubator. Exactly. You can do that. It's very, very easy. So it depends on what the egg incubator does, the type of sensor in the egg incubator, and the type of controller in the egg incubator. So you can use the HMI to program it. So if the incubator is based on RS485, I think if I go to, yeah, exactly. If the incubator is based on RS485, you can just connect the HMI directly. Let me use a pointer. The HMI directly to the incubator and control it. But if the incubator has another controller like PLC, so you connect the HMI to the PLC, and the PLC reads the temperature sensor of the incubator and feed it back to the HMI. So from the HMI, you can start the incubator, you can set the temperature of the incubator, you can monitor and see the way the eggs are doing and different kind of things you can do. So, and also depending on types of sensors you have on the incubator, you can get the feedback of those sensors from the HMI. Yeah, it's possible. Other question? Do we have another question? And the HMI is really quite easy to program compared to PLC. Okay, for now, I think we don't have open questions. We have answered the questions. So just try to get in touch with our marketing guys for other trainings we have. So it's quite a pity that due to this pandemic, our training has been online. Like this, what you have on this screen, you are supposed to really have a real practical demonstration. You just program the HMI to control this device. You see the motor run, you press stop on the HMI, the motor stops, you press reverse, the motor reverses. So it's just as easy as that, but because it's an online training, we cannot really do more than just give a general overview of how you program the HMI. Yes, for the type of sensors that the HMI controls, for example, there are some sensors. This is a question from Olango about which kind of PLC and sensor can match the DOP when I want to, make your machine. We have different PLC, like I think if you were in yesterday's training, Ufuk told us about PLC, and the prices are different. Some are very cheap, like this, I think I don't have it here, DVP. I'm not sure. Yeah, I think there's a place. Let me see if I can go to. There's this PLC where I talk about communication. Yes, for example, this place. Yes. You see, this one is we call it DVP. It's very cheap and simple compared to this other one, which is called AS300. So you can use AS300 if your system is really quite large and you need a lot of stuff to control. You can use PLC, this one and this one. And then all these PLCs, they have modules, a card you attach to them that read your sensor. So depend on what is the output of your sensor. Maybe your output sensor is current output. Maybe it's also a potentiometer like PT100. So you have a modules you connect to this to read your sensor. So the PLC you use depends on the price factor and depends on the functionality. And then mostly the HMI can also read some sensors that give their signal over communication. So maybe if you have a type of sensor that the output, it transmits it through communication, you can use it. But for like typical sensor like that you need to connect to a measurement module, the HMI cannot control that kind of sensor. It's only a communication sensor, maybe a sensor that is based on RS485, you can connect directly. But if that's not the case, and I think those sensors, they are also very expensive. But in a traditional case, mostly you connect your sensors to your PLC, and then the PLC talks to the HMI, and the HMI controls everything that has to do with your machine. So that's it. You can go for AS300. It's more expensive than this. You can also go for DVP also. Okay. So now, in the absence of other questions, I'm going to send out a poll to us. And that poll is about the feedback of this training. So we'd like to improve the quality of this training, also the content of this training. And maybe there are some things we are missing and something we need to add to the training. So that's why we sent out this poll. And this poll is very anonymous, so it doesn't show your name. So feel free to, if you want to criticize, you are free to criticize. Nobody will know who is criticizing. If you want to be polite, you can be polite. If you want to be harsh, you can be harsh. So the essence of this feedback is just we want to improve. We want to know what are we missing and what do we need to add to the training. Okay, I will send out the pool now, and then you fill the pool. And once you have filled the pool, you send it to us, and we don't know who you are. It doesn't show your name. So thank you very much. Please remain on the meeting as I launch the pool, fill the questions, and then submit it. So now I'm sending the pool to you. You must have seen the pool at your end. So once you are through, you will send the feedback. So please let us fill in let's answer the questions in this feedback section. So when you are filling everything, you send it, then we'll receive it as well. Okay, thank you. Yeah, 2 persons still have to complete the pool. Ufuk, I don't know if you have anything to say, Ufuk.
No, thank you very much, Victor, for today's session. Yeah, it seems everything is clear. And we already mentioned before, we are already contact each other. So in the future, if there is another question, yeah, they can reach us easily. So yeah, thank you very much. I don't have anything to add.
Yes, Ufuk, Olango is asking tomorrow which training. I don't know if he has registered for the training. Could you formalize?
Tomorrow is AC servo systems.
Oh, servo systems.
Yes.
So I'm not sure if he had registered for it already. If he hasn't registered, I'm not sure he can join.
No
Olango,
problem.
have you registered for the training?
I guess you know Justin, you already received an email from her. So I guess you have an email. So just send an email to Justin or me or Victor, doesn't matter. So it's not a problem. Yeah, tomorrow at the same time, there will be AC servo systems.
Okay, at 10 o'clock.
It seems and Friday is the robot in the morning, and afternoon is vision system.
Yeah, so he said he doesn't have a link to the meeting. I think you need to discuss with, could you send your email, Olango, please just type your email on the chat and send it to either myself, Victor, or to Ufuk. Then we can ask our marketing, and then we'll get back to you.
Yeah,
if it's
definitely.
possible.
Yeah.
Okay, yeah. Ufuk, have you seen his email?
Yes.
Okay, let me copy as well.
Okay,
and,
for the next trainings,
tomorrow,
yeah, we will send you a link.
Yes, okay. For the pools, there's another question again. Okay, I've got that. For the pools, let me see how many pools we have got. So it seems only 3 of us, yeah, have submitted our pools. So I think, let me see. Okay, I think we should end the meeting now. Please, is there still anyone that is filling the pool so that I can wait for you? I think 3 persons have already submitted their pools. Yeah, I think less than 5 minutes, we should close the meeting. So we are already through with the training, but we just need to get it as much as possible. Or maybe you need help on filling the pool, so you can speak, if we can help to direct. Okay, let me copy the email. Okay, just one. Okay, thank you very much. One pool has come in again. So we just wait for 1 minute more. Now it's 4 minutes. The pool has been launched for 4 minutes. 1 minute more, then we close everything. I think we have got 4 response. So guys, thank you very much for your patience and for your endurance, for also showing interest in data, to know about data. So we also have our technical support platform where we try to, support all your questions and the question you have for us and any issues you are having. So we really appreciate you so much. I think we have come to the end of our meeting for today. So other training begins tomorrow and other subsequent times. So thank you very much for your time. So this is the end of the training. So if you are through with your pool, you can as well dismiss as well. So thank you very much. Ufuk, yeah, said thank you to the people. Hello, Ufuk.
Yes, Victor, there is one comment. Just a second.
Okay.
Okay, Holakno, yeah, it's clear. We got your request, so we got your email address as well. So for sure, yeah, we will keep going in this direction as well.
Okay. Thank you very much, everybody. So the training has come to an end. So hopefully we'll meet next time. So have a nice day.
Have a nice day.